Hello, welcome back. Today we're going to continue our talks about domain and range of graphs, and we're going to look at some multiple choice questions and some piecewise functions. So just to review, what's domain and what's range? Domain are your x values, so that would be on your x-axis, and range are your y values, and that would be on your y-axis, which is also notated as f of x. They are the same thing. So just to review, what is the domain of the function to the left? Just to remind you, we want to consider the starting value and the stopping value for x. So which choice matches the domain of this graph? Here's how you do this one. If this is 0 on the graph, you count 1, 2, 3, 4 to the left, so that's -4. So I need a choice that has -4. The only choice like that is choice B, and also counting forward +2, so that works for B. Also, my inequality symbols have lines underneath, which I call more ink because the circles are closed, which also have more ink, so it matches. Okay, just to review, domain, we are just looking at the x-axis entirely, so only these values right here. When does the graph start? When x is, that's when x is 1. And when does the graph stop? When x equals 4. So let's keep this in mind for when we do some multiple choice. Okay, so let's say we are asked to graph this function, f of x equals x plus 1, but they only want it over this domain. That means you want to start when x is -4, and when do you want to stop? When x is 2. So I'm going to look at my table. Luckily my table is just big enough so that I only plot these points. So let's get to it. So -4, -3, I go left, 1, 2, 3, 4, down 3, -3, -2, -2, -1, -1, 0, 0, 1, 1 and 2, and 2 and 3. That would be my last point. If I had a ruler, I would draw a perfectly straight line from here to here. Let's say I put arrows to mean that my line would just keep going forever. So if I was to draw my line like this, imagine that it's perfectly straight, I could say, if I was a student, this student does not get full credit because I did not graph over the domain that they told me to. I was told to graph from -4 to 2, so from here to here, and that's it. So I don't want arrows, I don't want a continuing line, I just want a line from those points, and that's it. And I stop, and we'll talk about this in a bit, but if I have lines underneath, I want to make sure that my endpoints have closed circles. Let's look at a multiple choice. The actual question says the domain of this function is, so I'm looking at the x-axis. I numbered that for you. This one's a little bit tricky. The first question here, the graph starts when x starts at -1. The graph stops when x is, this one's tricky. Because what does an arrow mean? An arrow means it goes on forever. So that means it doesn't stop. So this doesn't make sense because it doesn't stop. It's infinite, goes on to infinity. So when I'm talking about my domain, I want to make sure that I mention it starts at -1, but then it goes forever. Let's look at our choices. Would the domain be all positive real numbers? No, because it doesn't include these numbers here. So it can't be all. And our next choice would be all positive integers. Nope, doesn't work because -1 is not positive, and that one works. So now I'm looking at my inequality ones. I think it's helpful to translate these to English. What is this symbol right here? I'll zoom in. So this means greater than or equal to 0. And this says greater than or equal to -1. So what do we think? Do we think that this is going to be all values greater than 0 or all values greater than -1? It's going to be choice 4, greater than or equal to -1, the or equal to because it's a closed circle, and 0 doesn't work because there are values before that. Let's look at another one. The domain of this function is, so which x value does this graph start at? It starts at -4. Count 1, 2, 3, 4 to the left. That is -4. Now let's look at when it stops. Does my graph ever stop? Nope, doesn't stop. Goes to infinity. So the only value that I can really talk about is -4. So let's look at our choices. I don't want to mention the ones that talk about 0 because I want to talk about -4. And based on this closed circle here, do you think I want choice 3 or choice 4? I want choice 4 because if I have a closed circle, I need to have a line underneath. Let's talk about piecewise functions. I think they're called piecewise because they're literally in pieces. It's a bunch of different functions or different types of functions on one graph, just in a few little pieces. So I know this might look like gibberish right now, but I'm going to fully explain. So there's two graphs here. Let's call them the blue and the red. So the blue, if I was to put that in the calculator, my line would look like that. It's got a slope of -1/2, and the y-intercept is 2. And if I was to graph the red one, I would have put this in my calculator. But they're already graphed for us, so we don't have to worry. So here's how this works. I have two different domains for each function. Let's pretend for a second that the red function doesn't even exist. Let's just look at the blue. So what would be my domain for this blue without thinking about inequalities? Just where's the start, where's the stop? So for the blue, it starts at -4, and then I always include x for domain, and then it stops at 1. And this notation just means that I'm going to have two different domains, so I want to have space for them. The blue one, the one on the top, is always going to be the one that's furthest to the left, and then the one on the bottom will always be the one furthest to the right of your graph. So blue is on the left, red is on the right. Okay. Now let's worry about my inequality symbols. So I have a closed circle, and just to remind you, closed circles get symbols with lines underneath, and open circles get symbols without lines underneath. So what would be my inequality symbols for the domain for blue? Since the first one is a closed circle, I get a line underneath, and the second one's an open circle, so I just have less than with no line underneath. All right, let's do the same thing for the red one. What is my start and my stop value for the red function? Well, it starts at 1. I put x for domain, and it stops at 4. And I have two closed circles using my cheat sheet here. What should my inequality symbols be? I want lines underneath for my closed circles. So this whole thing here, it looks kind of like a mess, but if you think about it, it makes sense. The top one, I'm talking about my blue function, the one on the left, and the bottom is my red function, the one on the right. It's just kind of mushed together. So whenever you see something like this, you're gonna have on this side, I'm gonna use a different color. This side is where they're gonna tell you what they are, what the graphs are, like -1/2 x plus 2. And on the right side, you'll get the domain. That's from like start to stop. And it's gonna be separated by a comma. And that's how you read something like that. But we'll practice a little bit more. Okay, let's do another one. Almost the exact same thing. So do you remember what is the domain for the blue function? That's going to be from -4, closed circle, so there's a line, x, open circle, so no line, and 1. Now let's look at our red one. This is where things are different. So where do I start and where do I stop for my red function? So I start at I start at 1. I'm just going to make a note here for red. Start at 1, but then it goes to infinity. I don't stop. So I'm going to be talking about 1, and I have my x here. Do you think I want a less than or a greater than? Do you think this arrow here is pointing to x values that are less or greater? Well, because it goes across 2, 3, 4, and 5, it's going to be greater. And do I want a line underneath? Let's take a look at my circle here. Do you think this circle means I want a line underneath or no line underneath? I want a line underneath. Closed circle means we're equal to. And then I just have to put 1. Like, what are we talking about? Well, it's all of these x values that are greater than or equal to 1. Let's do another one. Okay, now we got an arrow on a different section of this. Let's just cover the red domains, the same thing that we did the first time. The red starts at 1, closed circle, x, closed circle, 4. Now let's look at the blue. Where does my function start and where does it stop? Well, I don't know where it starts. There's no start. But I do have where it stops, so it stops at 1. So once again, I'm going to be talking about 1 and x. I just need to figure out my inequality symbol. So we want to decide less than or greater. Do you think this arrow is pointing towards x values that are less or greater? Because the arrow is going to the left, it's going to be talking about x values that are less. And looking at this circle here, do I want a line underneath or no line underneath? No line underneath. I want to keep it as less than because it's an open circle. And that's how you do a less than value inequality symbol for a function. Okay, let's try this one. So let's say you have 3 pieces in your piecewise function. I'm not going to make you graph anything today, but just so you know, there's 3 pieces to this function, and I'll try to color code them best I can. So that first one all the way to the left, right here, with the closed circles there, that's just x. That's the name of that function. That's what it does. Slope of 1, y-intercept of 0. And then we have one that's in the middle. See if I can get a little more purple. This line is just y equals 1, and that's in the middle, so it's in the middle there. And then the one at the end, our red one, it's the line 8 minus x. So you notice it goes in order from the most left to the most right on the graph, this being left, this being right. Okay, let's talk about our domains. It's all closed circles, so we don't have to worry. Let's look at just the blue one. What do you think the domain would be for just the blue line? Well, that goes from 0 to 1 in closed circles. All right, let's do the purple one. What do you think the domain would be for the purple line? So that is going to be from 1 to 7 close circles. Okay, let's do one more. The red one. What would be the domain for the red line? That is from 7 to 8. So I do 7, x, and 8. So that's how this works. You have your names of your functions, and then to the right of that you have the domains. So even though this looks crazy, you can read it now. So that's kind of cool. Okay, let's do another tricky one. So here we have multiple choice straight from the Regents. They want to know which one of these graphs goes with this notation. And I know this looks crazy, but we know how to read this now. The only thing I forgot to put are the commas. Okay, so just keep in mind the function on top is talking about the left side of the graph, and the one on the bottom is talking about the right side. So here's what you should do. The first function here, put that in blue, absolute value of x. When you graph it, it looks like this. Now I only want to see that kind of graph on the left side. So let's say I cover up the right part of each graph. Which choices look like this on the left side? That's going to be choices 2 and 1. Because they have the absolute value graph on the left. These just don't. Something else. So I can get rid of choices 3 and 4. Now for the graph on the right, if I put square root of x into my calculator and hit graph, I get something like this. Which one of these choices looks like that on the right side of the graph? That's choice 2. See, that looks just like that. So that's how you read something like this. The one on the top is left, the one on the bottom is the graph on the right. I didn't even really have to know any of that stuff. It's kind of cool. Okay, let's do one more. So we have 2 graphs here. The first one is the same, absolute value of x. I'll just color code it. That's your blue one. So let's take a look. I want to know which domain goes with my blue graph. When does it start? When does it stop? Okay, well, it starts at -6, stops at -2, so that gets rid of this choice here. And I'm going to go to my red one, since the other 2 blue choices are the same. So looking at the red one, where, let's see, both of these are the same for the start and the stop. The only thing that's different is the line underneath. So notice that I first have an open circle and then a closed. So looking at these sets of symbols here, which inequality says that I first have an open and then first have a closed? Well, that'll be this option here. Yeah, because we have no line and then we have a line. So that's your introduction to piecewise functions. There's a little bit more to do on this lesson, but I'll call this it for today. Just let me know what you thought of the lesson, and have a great day.